Is my screen visible? Today is lecture 10 and we will learn about inter-process communication and synchronization. Okay. What is inter-process communication? Well, I think all of you have understood what are process, when, or what is the definition of process. Whenever a program starts executing, it is known as a process. Inter-process communication, or IPC, it refers to mechanism where the operating system allows various processes to communicate with each other. What does communication exactly means? This involves synchronizing their actions and managing shared data. Now, means inter-process communication allows a program to handle many user requests at the same time. Why many user requests? Because due to handling of various user requests, inter-process communication is initiated. Since even a single user request may result in multiple processes running in the operating system on the user's behalf, the process needs to communicate with each other. The communication between different processes needed so as to handle or so as to work in multi-programming environment. So this is the definition of inter-process communication. The IPC interface makes this possible. Each inter-process communication method has its own advantages and limitations, so it is not unusual for a single program to use all of the IPC methods. This is the diagrammatic representation of inter-process communication, where we can say that two processes are communicating with each other. Now, for inter-process communication, a process can be of two types: independent process and cooperating process. Independent process is not affected by the execution of other processes, while cooperating processes can be affected by other executing processes. Though one can think that those processes which are running independently will execute very efficiently. In reality, there are several situations when this cooperative nature can be utilized for increasing computational speed. That means due to the cooperating nature of various processes, computational speed increases. Also, the concept of modularity is enhanced. Inter-process communication, IPC, is a mechanism which allows processes to communicate with each other and synchronize their action. Whenever we are talking about inter-process communication, then it should be kept in mind that synchronization is one of the important factors. The communication between these processes can be seen of cooperation between them. Processes can communicate with each other through both shared memory and message passing. These are the two ways or means of process communication. An operating system can implement both these types. That means an operating system provides support for shared memory as well as for message passing. Now we will look into the shared memory methods of communication, and then we will go to message passing. IPC cooperating processes. Independent processes cannot affect or be affected by execution of another processes. Cooperating processes can affect or be affected by the execution of another processes. What are the advantages of cooperating processes? Advantages of processes or thread executions are information sharing, computational speed up, modularity, convenience. What are the dangers of process communication? Data corruption, deadlock, increased complexity, requires process to synchronize their processing. Purpose. What is the purpose of cooperating processes? Data transfer, sharing data, and event notification. These are several purposes. Suppose, for example, if we consider that there are two processes, process 1 and process 2, they are executing simultaneously and they share some resources or use some information from another process. Process 1 generate information about certain computations or resources. Now, I want to share my whiteboard and want to draw a diagram. Let us draw a diagram. Is my screen visible to you? I am writing something. Is it visible?
Yes, ma'am.
Okay. Suppose this is process A. Shared memory. This is shared memory. Then another process, we add another process, we call it process B. There are two processes, suppose process A, process, this is at one side. And again, these are the separations between processes. Several separations are there between processes. Okay, now this one is the lower part. We will term it as kernel. Kernel. This is the core part. Now similarly we will draw a similar diagram in this manner. We will draw again a similar diagram where we will again draw, since it is inter-process communication, so we need to show the shared memory as well as message passing concept. Yeah. Again, we will write now here we will again write, sorry, wait, similar thing we need to write over here. Process A shared memory. I hope every one of you is studying at home. Today I have not checked what you have studied. In the last class I have told everyone to study. And again here it is process B. Then we will write kernel. Now this what is the diagram? Shared memory and message passing. Shared memory and message passing. What we will look, those who want, they can draw this in your notebook also. I was disconnected, so let me, the screen has already gone. So okay, the what I want to convey is that there are when there are more than one processes, or when more than one process is there and both the process they share the, or they communicate through shared memory, maybe they share the same memory, then we call it cooperating processes. Now we will look into the diagram. IPC mechanism. What is inter-process mechanism? Mechanism used for communication and synchronization. What is message passing? Message passing interfaces, mailboxes, message queues, socket, stream. Then we look into shared memory. Shared memory, variables and buffers located in shared memory region. Common examples of inter-process communications are synchronization, various primitives from spin locks to higher level mechanism such as monitors, implemented using either shared memory or message passing, debugging, event notification, condition variable, Unix signals. So these are common process of inter-process communications, which we have seen. Up to this point, if there is any confusion, then you can ask. Is there any confusion up to this point, or the what I have explained is clear? Since I
मैम मैम आप वो ग्राफ से क्या डिटरमाइन करना चाह रहे थे, एक बार बताएंगे? थोड़ा कंफ्यूज हो गया था।
okay,
जो प्रोसेस है शेयर मेमोरी।
wait, let me draw, let me see whether I can show the whether I can draw the graph again very quickly. Let me see if I can do that. Wait, just watch. I'm drawing it. Yes, that's what I was, that is why I was drawing the diagram, just to make the concept clear. This is process A. This was shared memory. Then this one is process B. This one, the spelling of the process is incorrect. All of you, when you will write in your notebook, write the correct spelling. Kernel now again here also we'll draw kernel B, process B, then again we will draw process A. So these were the different options which I was showing you. Now I have undone this. Wait. Let me again draw. All of you, please note down this. This will be helpful since an operating system, if you are giving exam, it is better to explain with the help of diagram. Diagrammatic representation makes the answer clear. Shared memory and message passing.
And the shared memory is the RAM.
Shared memory is the RAM. Okay, but it is not always like that. If you are talking about a network, then you can share the memory of someone, some other machine, some other nodes also, isn't it? So we cannot say that always shared memory is RAM.
Okay.
Is the kernel here?
Kernel is the lowest core part of the operating system. That is kernel. Actually, when we are talking about OS, it kept in mind the Unix operating system. Mainly the features of Unix operating systems were taken or considered, but here in this diagram by kernel we mean the core part or the inner part of the operating system. Okay, now let us go back.
Ma'am, just one more question. Ma'am, in an operating system, kernel is the code part, it processes all the system. So, ma'am, in the first diagram, the process A goes to shared memory and the shared memory goes to B. In that diagram, kernel is not in use.
It is not that kernel is not in use. What is the difference between these two diagrams is that process in the first diagram, process A and B, they are using shared memory. They are not using kernel. It is just a different way of communication, you can say. Here there, that is why in the diagram it is written shared memory and message passing. First one is for shared memory and second memory is for message passing. Like from kernel some message is given to different processes. Also some processes can give some messages to kernel. So with the help of message passing, multiple processes can communicate with each other, and with shared memory also they can multiple processes can communicate with each other. It is just the two different ways of communication. Is it clear?
Okay, so ma'am, in the first process, process A and B are communicating using the shared memory, and in the
Yes,
second diagram, it is communicating by the use of kernel.
very good. Yes, so I have covered up to this IPC mechanism. I have already explained. Wait, let me close this. So inter-process communication, sending process, message passing module, receiving process, message passing module to receiving process, and the message is, it is containing process ID and message. Why process ID field is present? Because if there are several processes that are communicating, then it becomes difficult to differentiate that which message is intended for which process. So with the help of process ID, this is taken care of. Since for each and every message, suppose there are 5 process 1, process 2, process 3 up to process 5. Now each and every message is contain process ID, that for process P5 these are the messages. So that is the need of process ID, so that data gets communicated properly. Inter-process communication, it can be divided into three parts: critical resource, critical section, mutual exclusion. Critical resource, it is a resource shared between constraints on its use. Example, memory, files, printers, etc. These are the resources shared with constraint. That means if a process is using the memory, then there are certain constraints also, that which area it can access or which area it cannot access. It is decided by the different privileges which is provided by the owner. Critical section is a new terminology for you all, I think. Critical section, it is a code that accesses a critical resource. Suppose, for example, if there are set of instructions which can change the course of the transaction, or which can change the steps, or it can affect the transaction, it can affect the process drastically. That portion is called critical section. For example, suppose if you have opened if you have opened net banking account, and I am also opening your I am also opening your net banking account, and you are deducting some money, you are transferring some money from that account, and I am trying to read that amount, what is the correct amount that you have in your account. So maybe at the time of transaction I am getting the incorrect data, because the resources are critical, they are shared, or it is a step of transactions that are crucial. It can affect the value of the total transaction. Don't worry, you will read critical section in detail in coming classes also. Mutual exclusion. Have you ever heard the word mutual exclusion? Have any one of you
No,
heard?
ma'am.
Okay. Mutual, yes? Okay. So mutual exclusion, at most one process may be executing a critical section with respect to a particular critical resource simultaneously. That means at a time only one process can be at critical section. If suppose one process is modifying the user data, then the other process will have to wait for the other process to get complete. Once the process gets completed, only then another process will enter. Is it clear?
No, ma'am. एक बार और बोलिएगा.
Okay. Mutual exclusion is, suppose if you are transferring rupees 1000 from your account, and I am the bank, I am also, suppose we have linked account, or suppose you and your father, Suraj and Suraj's father, both are accessing the same net banking account. Suraj is deducting rupees 1000 from his account, and his father wants to have a look what is the amount that is present at the moment, what is the balance. His father want to check that. So mutual exclusion, what it will do, when Suraj is doing some transaction, then he will not allow another user to read the balance. It will stop the user from reading the balance momentarily. As soon as the transaction gets completed, he will allow, or the operating system will allow the other user to read the balance. Is the example clear?
Yes, ma'am.
Okay.
Now it is somewhat like
Yes,
the
ma'am.
first come first serve. One process have to wait until the first process is completed completely.
Yes, you can say that, but it is not for all the sections of the code. Maybe there are suppose you and your father both are trying to read the balance at the same time. That can be allowed. There is no problem. Both of
That
them.
can, yes, ma'am.
It depends on the type of transaction that the user is going to perform.
Okay, ma'am.
This I have already explained with diagram, shared memory and message passing. Shared memory system, they require communication process to share some variable. The processes are expected to exchange information through the use of these shared variables. Responsibility for providing communication rests with the application program. This was the diagram, shared area of memory. The portion which is great, that is shared by different process S, D and C. Message passing system.
Shared memory variables means,
Repeat the question again.
say that they use variables. So what kind of variables they are using?
These are not variables. S, D and C, these are processes.
Okay, okay.
These are different processes. Name of different processes. S, D and C, these are different processes and they are using the shared variable.
Okay, ma'am.
Message passing system. Message passing system allows communication process to exchange messages responsibility for providing communication. I have drawn the diagram of message passing system also. An inter-process communication facility basically provides two operations, send and receive. Now, what is the function of message passing system? Its purpose is to allow processes to communicate with each other without the need to resort to shared variables. In message passing system, none of the shared variables are used. When we are talking about shared memory, sorry, then we are sharing the common memory area. It means variables also. We can share the same variables also. But in message passing system, the processes can communicate with each other without the need of shared variable. Shared variable need is eliminated in message passing system. Now, message passing system allows communication process to exchange messages. Responsibility for providing communication rests with the OS. That means for message passing system to work properly, operating system is responsible. Again, this point, in order to send and to receive message, a communication link must exist between two involved processes. Without communication link, send and receive messages will not work. Direct communication, each process that wants to communicate must explicitly name the recipient or sender of the communication. Send P message, send, receive, Q message. Send a message to process P, receive a message from process Q. This is indirect communication. What is indirect communication? Indirect communication is done when the messages are sent to and received from the mailbox. Then we can say that indirect communication is taking place. A process may communicate with some other process by a number of different mailboxes. Send a message to mailbox A, receive a message from mailbox B. Okay, this is indirect communication. That's all for today. I have taught you several new things. I will request everyone to go through what you have seen. I will share the video lecture with you also. Just go through what I have taught. So
Okay, ma'am.
I am stopping them. It will end now. It's already time.